Hello, my name is Aljamer El Misai from Master in Information Technology. So, this video is our midterm requirements, and also this video is all about breast cancer prediction, logistic regression with 97.9% accuracy. Then, so this all of the data sets are presented in this video. Then for the exploratory data analysis or EDA. So in this analysis involves an examination of the data to uncover patterns, spot anomalies, and test hypotheses. This process includes visualizing the distribution of key features and understanding their relationships with the target variable, which indicates whether the cancer is malignant or benign. Techniques such as histogram and box plots are employed in this dataset to summarize the data's central tendencies and variability. This data analysis helps in selecting and engineering the most relevant features, ultimately enhancing the performance of the machine learning model. Then for the future engineering has the feature selection and creating new features. So future engineering for this breast cancer dataset involves transforming raw data into meaningful features that improve the performance of the machine learning model. This process includes addressing outliers for the features identified above, which is area mean, area worst, perimeter mean, and perimeter worst. So, scaling techniques are applied to ensure that all features contribute equally to the model. Additionally, handling missing values and encoding categorical variables are crucial steps. So, effective feature engineering enhances the model ability to accurately classify tumors as malignant or benign. Then, the building a model. So, this consists of splitting the data that has a training set, which is to train the model, and a testing set, which is to evaluate the model. For the logistic regression involves the statistical method that is used for binary classification and also for the model training. So, building a model for this breast cancer involves choosing the most appropriate algorithm to distinguish between malignant and benign tumors. So this model, or datasets, estimates the probability that a given input point belongs to a particular class by fitting a linear decision boundary. For the model evaluation, this evaluation for this breast cancer classification dataset involves assessing the performance of the trained logical regression model to ensure its reliability and accuracy in predicting malignant and benign tumors. Common metrics for evaluating classification models include accuracy, precision, recall, and F1 score. So this dataset employ a confusion matrix to provide a detailed breakdown of prediction outcomes, showing the number of true positives, true negatives, false positives, and false negatives. This helps in understanding where the model is making errors. This also utilize cross-validation, which involves dividing the data into multiple folds and training the model also multiple times. Then each time using a different fold as the training set, testing set. This also helps in ensuring that the model's performance is consistent and not dependent on a particular split. Then, for the conclusion, this dataset concludes that the logistic regression model accuracy score is 0.9790. So the model does an extremely good job in predicting whether the tumor is malignant or benign. So the false positive rate is 3.26% and the false negative rate is 0%. So this model shows no signs of overfitting. The increasing the value of C results in higher test set of accuracy, but slightly decreases the training set accuracy. So I conclude this model or dataset that a more complex model might slightly overfit.